Hey, what's up, guys? So, I've been getting a few questions in the comments lately about how I set and clear bits in registers like this. So, I thought I'd make a quick video here to explain exactly how that works. But first, I want to test something out. Some of you might remember a while back in my LED cube project videos that I had to speed up my digital writes by manipulating the port registers like this. So that sped up my digital writes, but I never really got into how much faster that sped it up. So I put together a little circuit here that we can measure how much faster it is to do this technique versus this technique in your Arduino projects. So let's take a look over here. Okay, so we've got two standalone Arduinos here hooked up exactly the same, both running at 16 megahertz with 5 volts applied. And you'll notice that we've got a push button hooked up here that's wired up to both Arduinos. And if we jump over to the code here, that'll make a little bit more sense. So basically what we've got here is an LED on pin 4. We attach an interrupt to interrupt 0, which is digital pin 2. And the push button actually grounds this pin. And we've got a pull-up resistor hooked up there, so as soon as you press that button, it pulls this pin low and triggers an interrupt, and this function here is called digital interrupt. And then it blinks the LED. And on the LED output, this pin 4 here, I've got the scope hooked up, so both channels are hooked up to both of the Arduinos. And the idea here is that we'll change the way at which we're writing digital pin 4. And the idea here then is that when you press the button, both interrupts are triggered at the same exact time or within a few clock cycles, but that time difference we're not worried about. We're looking for something much larger than just a few clock cycles. And we'll watch on the scope the difference at which the pin is turned on and turned off. So let's go ahead now and benchmark this. So right now they're both running the same exact code, and up on the scope we should see that the turn on and turn off time is exactly the same. So let's go ahead and push the button. You can see that the LED does flicker there, and we'll turn it on. Let's first look at the rising edge of that. Okay, move that over a bit, and you can see that indeed it is turning on that LED at the same time. So both of the we can see both channels are pretty much in sync. We've got 1 microsecond per division up there, so it's pretty close. On the falling edge, we can take a quick look at that. So there you go. You can see the turn off time is also pretty close. So now let's change the code to this Arduino to directly manipulate that port instead of doing a digital write. So let's do that real quick. Okay, so now I changed the code on this Arduino so that now it's doing a port D or equal with 1 shifted over to the left 4 places. And I'm going to explain how this all works here in a second. But first, let's just test it out. So this is writing the digital pin 4 high, and then we're doing this to write it low. And this is an AND equal with the inverted 1 shifted over to the left 4 places. So let's test this out. So again, this one's doing a digital write. This one is doing the direct port manipulation. And let's look first at the rising edge. And right away you can see on the scope there a huge difference. So this is with the direct port manipulation. This is with the digital write. And if I can kind of line that up, we're doing 1 microsecond per division. So if we count that out, 1, 2, 3, 4, it's about 4 microseconds faster. So that's pretty good. And this is 4 microseconds to turn the pin on or write the pin high. Let's try and see what the falling edge looks like here to see how much faster it is to turn the pin off. Oh boy. Okay. Might have to move that over. There it is. Okay, and it's much faster to turn it off. And you can see we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 microseconds now. So it's about 9 microseconds faster to turn the pin off or to write that pin low, which may or may not matter to you. Depends on your application. When you're talking about high-speed multiplexing, like when I was working on the LED cube project, this was a huge difference, and I needed every microsecond I could get to turn those pins on and off. So that's an application where it's extremely important. So anyway, now you can see how much faster it really is to do your digital writes by using this technique instead of just the digital write. So anyway, now we can get into exactly how this works. Okay, so the first thing I want to talk about is how did I know that that digital pin 4 was on port D here and it was bit 4 on port D? Because, you know, why not port C, port B, or anything else? And when you look at your Arduino board here, you've got all of your digital pins hooked up, and it's showing you, you know, digital pin 0 through 13, then all your analog stuff and everything. But what you need to know is what pins physically on the AT Mega those pins go to, those digital pins within the Arduino environment are hooked up to. So to do this, just simply Google, you know, Arduino Pin Mapping, and you'll come across this little diagram here which shows you all of the digital pins that you're used to within the Arduino environment and how they're mapped over to the physical pins on the device. So we had the LED hooked up to digital pin 4, and you can see that it's mapped over to PD4, which is port D bit 4. So I mean, the 4 part of it makes sense, and that's pretty easy. And if you keep going down, you see pin 5, 6, 7, PD7. And then when you get to digital pin 8, it goes back now to PB0. So now you're on port B, and it continues around and goes all the way up, and then all your analog stuff is on port C. We're actually using ADC0, ADC1, and that stands for your analog to digital converter. You can also jump over to the data sheet here, and it'll show you the pinout. And you can scroll down. It also shows you how to toggle pins and things like that, which we'll also get to here in a second. And just a side note, I did design a board here, and I'll put a link to this page in the description, and I call it the cheater board, and it kind of helps you out with seeing what the Arduino pins are versus what the AT Mega 328 pins are, and it shows you alternate functions, so it comes in handy when you're doing a lot of timer PWM stuff. So anyway, that's just a nice little thing. It also has the bootloader, or the in-circuit serial programming header pinout. So it's just a nice little cheat sheet, and it also runs the Arduino compatible circuit here so that you can program it with a standard USB to serial converter. So anyway, I'll put that in the description below. So that's how you know which port and which bit you need to flip. And now we can get into exactly what this business is doing, this OR equal and this shift over thing, and then worse, when you're turning it off, what does this AND equal, what does this thing mean, and all that stuff. So let me show you that now. We'll jump over to the whiteboard and get into that a little bit. Okay, so just a quick explanation about how this math works. Let's just take a port D, and say that it's already equal to this, okay? Some of the pins are written high, some of the pins are written low. This is the existing state of that port, and this could also be a register or anything else. And what we want to do is flip a single bit within this port without affecting any of the other bits. And that's basically what we're doing here. So what we do is we take, let's say we want to flip bit 4 or digital pin 4, and we want to write digital pin 4 high. What we do is just take a 1, shift it over to the left 4 places, and that gives us a value of this. Okay, so we take the 1, shift it over 4 places, 1, 2, 3, 4, like that. And then when we OR that value with the original value, we're left with 0, 0, 0, 1, 1, 0, 0, 0. And you can see how we just flipped bit 4 high. And basically, in my code, which I just showed you, that's exactly what we're doing. We're going port D or equal with 1 shifted over to the left 4 places. So this or equal is taking the existing port and just ORing it with 1 shifted over to the left 4 places, which is this value. And then your end result is this. So it's a nice clean way to write a single bit high on your port or register. So now let me show you how to turn a bit off or flip a bit off or write a pin low. Okay, so now we've got digital pin 4 high and we want to turn it off. So what we do first is the same exact thing. Let's take 1, shift it over to the left 4 places. We got 0, 0, 0, 0, 1, 0, 0, 0. I should probably be writing bigger. Hopefully you can see that. And then we're going to invert that value. So we're actually left with 1, 1, 1, 1, 0, 1, 1, 1. And then forget about this value. And then we AND these two together. Okay? And what this ends up with, so we AND that, that's a 0, we AND that, that's a 0, 0, we AND these two values, we get a 1, we AND these, we get a 0, we get a 1, we get a 0, and a 0. So we left everything else untouched except bit 4, which we flipped now to a 0. And in code, like you saw before, we're doing port D is now and equal, to the inverted value of 1 shifted over to the left 4 places. So this shifted over to the left 4 places. We took that, inverted it into this, and then took the original port and ANDed it with that whole thing here to get this. That's how it works. And from this, I think you can figure out how I was able to flip multiple bits at the same time from my last low power series videos and all of that. But that's basically how the math works, and it's as simple as that. So hopefully that kind of clears things up, and maybe this whole video will help you speed up your digital writes, and you'll be getting your cube working and fast, and any glitches you might already have, like I was having with digital writes, will be fixed up with help by manipulating ports directly like this. So anyway, that's the video. Thanks for watching.